Okay, so we've already looked at the United States Geological Survey topographic maps, not as part of this presentation, but part of a previous one on maps. So you should sort of recognize what this is. This is the upper left corner of a typical USGS 7.5 minute or 1 to 24,000 topographic map, okay? And what I want to show you, right, more than anything, is up here in the upper left corner, typically in the upper left corner, usually in 2 corners, sometimes in 4 corners of the map, they show the complete UTM coordinate, right? But they show it in a bit of a funny way, right? This one is the Easting, right? And I would assume, I think that it's the Easting for this vertical line, which is hard to see, but that's the vertical line, right? And it says 5, little 5, big 99, and then 3 zeros, and then M for meters, and E for Easting, right? So what that means is that the Easting of that line is 599,000 meters, right? Now, if you look in the bottom left corner of a USGS topo map, as we will in a minute, you'll see that it says that they've marked the 1,000 meter, there are tick marks at the 1,000 meter intervals of the UTM system. So they don't mark every meter, they mark every 1,000 meters, which is every kilometer, right? So this is 599,000 meters east. The next one is going to be 600,000 meters east, right? And one of the things that we're going to do, and that you need to know, is figure out, for example, if you pick an arbitrary point, how many meters east is this point? Well, some arbitrary point here, oops, didn't mean to do that, but it's okay. If we know the scale of the map, to figure out the easting of this point, what we need to do is measure east from this line. We know this line is 599,000 meters east. If we can measure a certain number of meters east of that line, then we know that that point will be, let's say this is 400 meters, right? Then the easting of that point will be 599,400 meters, right? 599,000 plus 400, or 350, or 560, or whatever the distance in meters from the line to the point is, right? That'll be, that will be added to this number, and it will replace those 3 zeros, right? Now, this here is the northing, right? And it's the northing of this horizontal line, right? So what is that number? 4,206,000 meters north, right? That's the distance north of the equator in meters, right? And as with the easting, they only mark every 1,000 meters, right? And so if we have an arbitrary point located there, like just under the 4 there, right? If we want to know the northing, what we need to do is measure from the line straight north to the point, calculate how far that is in meters, and then add it to the northing of the line that we measured from. And that will give us the true north coordinate of that particular point, right? So we can measure north from a known northing and add on the difference to whatever that north coordinate was. And we can do the same thing by measuring with the easting, by measuring east from a line whose easting is known, and add that to the easting of the original coordinate for the line or tick mark on the map. Now, I know somebody would ask, because I've taught this 27 times, well, what about if you're over here? What if you're west of the line? It's like, well, you can measure meters to the west and then subtract. It's always better to add, if you can, because you make fewer mistakes that way. But in a case like this, you can't measure east from a known line because there is no line over there. You have to measure west because the only line that you can really measure east and west from is that one, right? In this picture. So, you can measure west and subtract, but it's almost always better, when possible, to measure east and add rather than measure west and subtract. Okay? Now, let's go over to a real map and hi. Not a problem. Let's go over to a map. Actually, there's a I don't know what I'm filming here. Let's go to the next slide and look at the next slide before we go to the real map, because this illustrates what I was just explaining, right? If this yellow and gray circle is the point you want to calculate UTM coordinates for, right? You can measure, in this case, 832 meters east from this line, which is 706,000 meters east, right? You can measure east to your point and then add that, right? So you start at the 706,000 meter line, and then you measure 832 meters east from there, and what you get is an easting of 706,832 meters east, right? You can then also measure north from your UTM line. Your UTM line, it may be difficult to read here, but it's 4,344,000 meters north, right? And then you measure north from that line to your point to get the full coordinate, right? And in this case, it's 683 meters from the line, right? And so you add this to that, and you get 4,344,683 meters north. And so the coordinate in the UTM system for that point is 706,832 meters east, 4,344,683 meters north. And for your UTM coordinates to be complete, you have to specify the zone. If you don't specify the zone, then there's at least 60 places on the globe with those same UTM coordinates. So you must specify the zone. In this case, the zone is apparently 10S. S is for south. I don't know where that is, but we could figure it out. But where in the United States? 10 south. The only thing I can think of is Puerto Rico, but I'm not sure. At any rate, one question is, how do you measure this distance in meters, right? How do you measure these distances in meters? Well, the simplest way is to use a transparent little grid like this, right? UTM coordinate grid. And they have special grids that are ticked off in meters for different scale USGS maps. And this is the one, you see it says scale 1 to 24,000. This is the one you would use for the typical topo maps that we use in field science, right? They also have one that's, I think, a 10-minute map maybe. That's only for Alaska. And they have some other scales for other maps that the USGS either produces or used to produce. The problem with using this grid is that, first of all, they're expensive. They're, like 20 bucks a piece. And you got to buy them from vendors. The government doesn't make them, I don't think. And, you never have one when you need it. So, you can, you don't have to use this special fancy grid that's been scaled precisely for that map. You can use any ruler at all. I have one here. Somewhere, here it is. I have a little FAU field ruler here. And it's very difficult to see, but they do have millimeters and centimeters marked on the scale here. And you can just measure on the map, and then use the scale of the map to convert those measurements to meters, okay? So I will explain how to do that in a minute. But before we get to that, let me show you one of these USGS maps, okay? So, you know, there's a map. It happens to be, I believe, of North Miami, right? And these are the typical maps that we use. If you look in the northwest corner here, you will see, if my camera focuses, which it's not doing very well, you'll see that you have latitude and longitude marked here, but we don't really use that very much in practice. But here we have, is that out of focus? I don't know if it's in focus or not, but that's the North UTM coordinate. And you can see, I hope, that it says 28 in small numbers, 28, 75, 000 meters north, right? So that means that the northing of this line, which is hard to see, but it's marked on the map, right? That line is 2,875,000 meters north of the equator, right? And here is the Easting, 576,000 meters east. So this line, this vertical line here, is 576,000 meters east. Now, one of the many confusing things about this, I do not know why this is not focusing better. I don't think it's the battery. Oh, okay, there was some weird focusing thing going on. Let me try that again. Let me show you again here. So that's the 576,000 meters easting coordinate, and this is the 2,875,000 meters north coordinate, right? Now, if you look at the next coordinate, the next UTM tick mark below that, which is here, right? You'll notice that it doesn't have the full coordinate. It just says 2874. And that's just sort of an abbreviation. It's a truncated version of the UTM coordinate. And what that means is that it's 2,874,000 meters north. What they've done is they've just to save space and to make the map simpler and easier to read, they've gotten rid of the 3 zeros, the M for meters and the N for north. And as you go down the map, you'll see that the other UTM coordinates, which are 1,000 meters apart, right, are all shown in that same format, right? Some of them are not marked, actually, because there's something else printed there, right? But here's another one, right? Here we go. 2,867,000, 2,866,000, and so on and so forth until you get down to the other corner here. Also note that the UTM zone is shown in the legend, right? 1,000 meter universal transverse Mercator grid, zone 17, right? There's another important fact here. It says 1920 1927 North American datum. I'm not sure if we've talked about that yet, but we no longer use the 1927 North American datum. So you would need to convert the coordinates from the 1927 datum to the 1983 datum, and we'll talk about that later. Okay? So, as with the north coordinates, the Eastings are abbreviated as well, right? They give one in its complete form, right? 576,000 meters east. And then the subsequent ones are abbreviated or truncated by removing the 3 zeros, the M for meters, and the E for easting. So it just says 577,000. 578,000 is here, and you can see there's a line. I don't know if you can see the line, but there's a line there, right? But it's not labeled because there's something else written there. Then we go to 579. So if you need to use the 578,000 line, you have to infer its coordinates by looking at the ones on either side, right? And then 579, and then there's another one that's not labeled, and another one that's not labeled, and then there's 582,000. 583,000 is not labeled, but 584,000 is labeled. The next one's not labeled, the next one's not labeled, but 587,000 is labeled. And then there's, I think, another one here that's not labeled, right? So the point is, the idea is, if you need to know, for example, where this building is, right? You need to measure east from this UTM line and north from this UTM line and calculate how many meters it is from each line, and then add those meters to the coordinates for the tick marks. And we'll do that in the next video.